Hello. Here is an example of given a situation, make a table and a graph and write an equation for it. So the example here is the population of a town is currently 40,000 and is increasing 2,000 people per year. So question A is make a table for the population for years 0 through 4. Okay, so we have, let's make the table over here. So we have year and we have population. I'll just do pop for short. Okay, so here's our table. So year 0 means right now. So year 0, the population it says is 40,000. So write 40,000 people. Okay, 1 year later, it says that the population is increasing 2,000 people a year. So it's 40,000 plus 2,000 is 42,000. Okay, year 2, the population goes up another 2,000, so now it's 44,000. So just add on 2,000 people. Year 3, another 2,000 people, so 46,000. Year 4, and that's the last year that we're asked to do. Here, year 4, another 2,000 people, so 48,000. Okay, that's it for part A. Okay, part B, make a graph of the population. So we can just take our table right here and make a graph out of it. And so here, first of all, we need a little bit more space here. Let's move part C down a little bit here. Okay, so for scaling here, I'm going to go for the x-axis. X is years. So I'll just go by ones because we're going 1 year at a time. So here's 0. I'll just put a little tick mark. That's 1 year, 2 years, 3 years, 4 years. And for the population is going from 40 to 48. So I'll go by I guess I'll go by 2000s here. So I'll start here at 40,000. And if you wanted to, you could write like just 40 or 40K if you wanted to. I'll go ahead and just write the whole number out. 40,000, 42,000, 44,000. Now it's just a judgment on my part to increase by 2,000. You could increase by 5,000 if you wanted to. That would be fine as well. 46,000, 48,000. And I might as well go up to 50,000 just so we have rounded off here. Okay, so according to the table, in year 0, we have 40,000 people. So put a little dot. Here, let's do another color. Let's do red. All right, a little dot here at 40,000. Okay, and then it says after 1 year later, 2,000 increase, so 42,000. 1 year later, 42. 2 years later, 44. 3 years later, 46. 4 years later, 48. And just approximate this. If you have graph paper, that's better. You can make your scale a little bit more accurate, but this is good enough. If you want to keep going, you can go year 5 is 50,000, but I think we see the pattern here. So then just draw a line to indicate that's the direction of the trend. You can draw a little arrow to indicate that the increase is continuing. Okay, and then part C. It says write an equation for the population. Let x equal the year and y be the population. Now, if you're not sure how to, let's go back to black here. If you're not sure how to write out a formula for anything, you can just pick a number. Like let's just pretend for a minute that we want to calculate the population, let's say, for x equals 3. So after 3 years, remember x is the population. Now x is going to be a variable. This is just to get us started. So what is the calculation? Well, we're starting off here with 40,000 people. So my calculation is 40,000 people to start off with, plus 3 years times 20,000. So 20,000 people per year times 3 years. Okay, so what is that calculation? That's 40,000 plus 20,000 times 3 is 60,000. Hold on, hold on, hold on. I have one too many zeros. Sorry about that. Let's get the eraser here. It's 2,000, not 20,000. That would be more than doubling after 3 years. That wouldn't make any sense. All right. So it's sorry about that. It's 40,000 plus 2,000 times 3, which would then be 6,000 when you multiply it, which is then 46,000. Okay, and that indeed is what we got from the table. After 3 years, we did have 46,000 people. All right, now let's write the formula. After doing the arithmetic with an actual number, now let's analyze what did we actually do here. Well, first we took the current population, and then we added on to that the rate, 2,000 people a year, times x years. So the formula here is y is the population. Y equals 40,000 people plus 2,000 people per year times x years. Because x isn't 3. We're just pretending x was 3 just to get us started. But it says write an equation where x equals the year. So x stays the variable. So there is the answer. Now notice that we have the a plus bx format here. So let's compare the equation back to the graph. So the y-intercept is 40,000. And sure enough, on our graph here, the line crosses the y-axis at 40,000. And the slope is 2,000. And if you look at the graph here, from this point up to this point, what is the slope of that? Well, I go over 4. I go up from 40 to 48,000. I go up 80,000. I go up 8,000. 8,000 divided by 4 is sure enough 2,000. Okay, so it all comes together. The slope really is 2,000 because the population is increasing 2,000 per year, and the y-intercept, think of that as a starting point, is 40,000. So we do have our equation right here. And a lot of the equations in the homework is like this, where you have some starting point plus or minus if it's a decrease, some rate times x. And that's it.